स्क्रीन दिख रहा? तो let's go discussion for Codeforces around 1006 div 3 A to F. Let's start with A. The question is, the system provided an array of n zeros, integer k and integer p. You can choose an index I and x such that x is between minus p and p, and assign ai with x. Now this person needs to figure out if I can make the sum equal to k. So I have, let's say, these arrays, all of them have zeros, so putting a zero or just keeping them empty doesn't really matter. Now one thing to notice is, k being negative or positive, it is always beneficial to me to take p, and then some number x here. Why? Because this minimizes the operations. Correct. And if it was negative, I just take minus. That's it. So from this you figure out कि minimum moves equals k by, I'll do this, k by p, and this is absolute value of k by p, and this is seal function. Basically, seal function, if you want to implement in C++, instead of using the seal function directly, you can do this by p. This does seal for you. Now the only thing you need to take care of is, where does n come into account? If minimum moves is greater than n, then minus 1. So that is the crux of the problem. Looking at the code, I take in the input, I take the seal, and after the seal, I just, if it is greater than n, so it's minus 1, and I print the moves. That's it. Any doubts here? I guess no. So moving on.
Clear, sir. Clear.
Now moving on to B. B, there are the dashes and underscores. You need to rearrange now your score is the number of subsequences with this there. Okay, so this face basically. Now you need to figure out, you need to rearrange the characters such that the value of s is maximized and print the maximum value. Now main thing to note is, like, the underscores, you can just keep them together because for each underscore just keep the answer same. Why is that? Because if you keep it different for a different, like say you put a dash in the middle, this one will have a lesser count than all these. For example, it might have a lesser count. So it's better to keep the underscores together. Now how do I distribute the dashes? So one thing you can do is, here you can do n by 2 seal and n by 2 floor. So if you distribute this, for each of these underscore, the number of subsequences this will be a part of is number of dashes to the left. Well, basically it is left into right. Okay, so that is why this part, like if you divide it equally, this multiplication maximizes. And since this multiplication maximizes, what you can do is left into right into underscores, because for each underscore the answer is going to be the same. So left is what? So left is n plus 1 by 2. This is basically ceil. Right is n by 2, which is not n dash plus 1 by 2 dash by 2. So this is your formula. You can get this by counting the dashes and counting the underscores and printing the answer. To print the like looking at the code, my ones is basically the number of dashes, and 0 is basically number of underscores here, and I just take ceil, floor, and then I multiply it with 0. So that is your answer. Cool. So I guess moving on to C. Now here on out I'll ask doubts because yeah. So for this question, you want to make an array of size n such that the OR of all numbers is x, and you want to maximize the max. Okay. So now what is a max? Max is minimum non-negative integer z, such that it isn't in the array itself. So to maximize the max, what should I do? What should my array be look like? It should look like this, right?
Yes, sir.
So this maximizes max, but now this not necessarily makes my or x, right? So how do I take into account how much should my max be and what should my other numbers be like, right? So now for every number, what I'll do is I'll add to OR only if all set bits in I are set in X. So what do I mean by that? For example, let's say I have a 3, which is let's say I have 4, which is 1 0 0. Okay, I want to check if I can take this into my or not. If my target X, okay, target X was something like this. X equals 1 0 1 0. Okay. So then, if I take this OR, will I ever be able to achieve X? No, because
No, sir.
OR mein whenever you include, it always remains set. So this is where I do check कि all set bit is in I, if I want to take I, are set in X. How do I check this? There is a simple check. You can do X and I equals I. Basically, this ensures that all set bits in I are set in X. Because when you take AND, only when all set bits are set, you will get the same AND. So that is a check. That is when you include. Now what if this doesn't hold? Like for example, I can't add this. Then my max will be this itself. Max to change nahi hone wala.
Yes, sir.
So for example, I have 0, 1, 2, 3. 4 I can't add. So what I can do is, बाकी सब I can fill with zeros, and जो last number है, I can basically set it as the remaining part, XOR of current or basically current or XOR X. This basically gives me all the unset bits, basically the bits in X which are not set in cur. So I just take that value. in the end. Does that make sense? Current OR is basically OR of every single number up to like basically a0 or a1 or dot 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 an minus 1. So that is cur OR, and that XOR x give me the last value, and this is await n minus 2. And this value I set to a of n minus 1. That's it, and then I print the array. And yeah, now one thing to notice, for example, I have 0, 1, 2, 3, 4, 5. And now I need to add the last number. Instead of doing the XOR, here my max can still be 7, right? So I'll try adding a 6 also. So that is the extra case. Case 6 also try to add, and that's it. So looking at the code, I go from 0 to less than n minus 1. I check the condition, and once I check the condition, I set ai to I get the current OR, and I increase my max. Now, what is this? I want to set the last number as my current max, which is not set. So I just OR max and max or x. If it is equal to x, then fine, I set it to max, or else I take the XOR. So that is the
Sir,
main
can
thing.
you please explain? Can you please explain this line again?
With this one,
Yes, sir. Yeah, if and else condition.
okay. So now, wait, I'll take the example. I think this is where it was 7, huh? When I have n and k as 7, 7, till, wait, huh, 6, so I don't put, loop till n minus 2, basically. So
Yes,
this I
sir.
have done. What is my current OR? Equals 7, right?
Current all is 7. Yes, sir. Three
Huh,
bits are already set from the
exactly.
left hand side.
Now, what is the best thing I can put over here? Like,
Yes, sir.
putting
I can
anything
place.
between 0 to 7 is fine, but putting 6 is
But
always better, right?
placing 6 would automatically give me the best answer. It would increase the max.
Exactly. So that is where I check this if condition. Ki if I can include this max, ki I take this max in my answer, so my current OR becomes like, I take the OR, no, basically, with my current OR.
Yes, sir. Yes, sir.
And if it is equal to x, then fine, I make it the max. Or else,
All right, sir.
this is the last case where, for example, I have, wait, 0, 1, 2, and now I need to make something. I need to make this x equals 7. My current OR is 3. So now what do I require here? I require a 4 here.
Yes,
So
sir.
what is that? 3 XOR 7. So that is why it's a XOR.
All
Instead of
right.
doing this dot thing, we can directly do is equal to x.
Hmm. Exactly. Makes sense. You can take x also because it's OR. Makes sense. Yeah. Instead of this, you can just remove this part and just keep it x. That is also fine.
All
Perfect.
right, sir. And we can also use the subtraction method, isn't it?
Subtraction as in?
I mean the x minus answer.
No, no, you can't do that, because then, for example, let's say, like in this case it is working, but let's say I require a 12 and my OR is 6. So now my OR is 6. If I subtract, what will I get? I'll get 6, right?
Yes, sir.
What is 6 or 6? Equal to
6.
6. Now this is not equal.
Oh, all right. Thank you so much.
Uh,
Thank you so much.
so that subtraction doesn't work. Setting it as x or taking XOR works. Okay. Now moving on to D. So in D you're given an array and you want to select a subarray LR and modify it such that you basically do a cyclic left shift. Where is it given? Cyclic shift to the left. And if you see over here, this subarray AL to AR becomes AL plus 1 to AR, AL plus 1 to AR, and then last mein AL gets added. Basically this index goes to over here. Okay. Now everything else remains the same. Now that is a very important thing to note. I'll just visualize here also. For example, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay. I want to choose this subarray. What will happen is 1, 2, 4, 5, 6, 3, 7, 8. Okay. So what happened is 4, 5, 6 came here, but 3 shifted, like 3 jumped ahead. That's it. Baki sab are as it is. Now what you want to do is you want to minimize the number of inversions. What is the number of inversions? It is pair of indices ij such that I less than j and bi greater than bj. In short, for every number, the inversions it is part of is in the future, like whatever number are ahead of me. Wait, inversions is summation I from 0 to n minus n for each number. Okay, for each index I check number of lesser numbers ahead of me. Basically this is, in mathematical terms, it is count of aj such that ai greater than aj and I less than j. So now ahead of me is this part and lesser numbers is this part. Okay. So now that inversions you can count directly using n square ki for every index I check in the future, or you can do it inverse also. Okay, you can check in the past. Doesn't matter, same thing. Now let's say I want to swap these around. Basically take this subarray and cyclic shift. What will happen is, like इसका जो contribution था, what was its contribution right now? All the future lesser numbers. Look, I'll take a better example. 3, 1, 4, 2, 6, 7. Okay. So now 3 के लिए how many numbers are lesser? 2. 1 के लिए it is 0. 4 के लिए it is 1, 0, 0, 0, 0. Okay. This is my contribution. My total inversion is summation of this. Now if I want to cyclic shift, what will happen? 1, 4, 2, 3, 6, 7, 8. If you see, for this 3, the ahead included the things inside my subarray, right? If I'm considering this subarray, ahead is all the numbers excluding me in the subarray. Yes, no?
Yes, sir. Yes, sir.
Huh. So now, if I want, like, so now technically I should subtract 2 from here, correct? From total inversions, जो 1
Yes,
2
sir.
था इसका, those are now before me. So I subtract 2.
Yes, sir.
That's fine. Now I also need to check पीछे how many greater are there than me, right? Because now some things can be greater than me, correct?
Yes, sir. Yes, sir.
Huh. Now for the numbers greater than me, I also get the count. So now if I take a subarray, score of a subarray is equal to, पहले तो ओरिजिनल इन्वर्जन्स माइनस लेसर देन AI in subarray plus greater than AI in subarray. That is it. That is my score. Does this make sense? Hello.
Yes, sir.
Yes.
Understood.
Huh. Cool. So now this you can also do it in n square. So coming to the code, like
Sir, I need
forget.
to ask you one thing.
Huh.
Actually, when I first saw the question, it was, n is going till 2000 and the test cases are 10 to the power 4. I
Hmm.
neglected the idea that brute force would work here because it would give me TLE, but it's
Huh.
not giving the TLE right now.
This is the thing. Sum of n square across all test cases doesn't exceed 486. So you
Oh,
can
all
make
right.
sure कि n square will work.
All right, sir. All right. Thank you so much.
So whenever there are test cases in n, always read this line because this helps. For example, in this is mentioned for I think G, number of sum of test cases not bounded. That means here I can't do O of n per test case. While there I can do O of n square by per test case. So this is very important.
Oh, all right, sir.
Huh.
Genuinely, thank you so much. Thank you so much.
No worries. Now, the way I calculated inversions, don't worry. You don't really need to care about that. I'm doing this in n log n. You can read about this, but you can do it brute force also. That's fine.
Could you
Now,
send me
then
the
what do I do? Huh?
could you send the article where I could read what's in between chat later?
Okay. N log n inversion count. I think count inversions. Count inversions in n. Where is it? Brute force. You can do
Sir,
with merge
for the
sort
beginner
also.
guide of Fenwick tree, could you please suggest some resources from where I could learn the Fenwick trees?
Fenwick tree is not really necessary for people to learn. I just learnt it because that is there. You can do segment trees also. Segment tree can, basically segment tree, everything segment tree can do, Fenwick tree can do. But Fenwick tree is difficult to understand how it works. So even like very high rated people, like for some people, if you don't understand, you can just implement. That is fine. But if you want to understand, it is kind of difficult to learn. You can just search Fenwick tree CP algorithms, and you'll get this blog. You can also search on YouTube. There are many videos on this.
Right, sir. All
And
right. Thank
same thing segment tree. and segment tree also CPU algorithms is there.
All right, so thank you.
And count inversions, I'll just mention like fnvic tree. You just read upon it, you'll understand a bit. Thoda time it'll take. So then now coming to, after I've calculated original inversions, you can do it in n square. That's fine. Now I need to store the answer L, answer R. So what is that? If I don't want to change anything, I just take a subarray of 1 comma 1. So that is why I'm doing plus 1 because I have 0 base indexing. So worst case, like I'm doing nothing. Inversions I can't do anything. So 0 comma 0 I swap. Basically I do nothing here. Now what do I do other than that? For I goes from 0 to n, I get that value. Basically I need to compare that with everything else, and I store number of lesser and number of greater than me. Originally everything is 0. Now going from I plus 1 to n, the j loop, I increment greater if aj is greater, I increment lesser if aj is lesser, and then this part, this you get from this only. Original inversions, lesser minus lesser plus greater, original inversions plus greater minus lesser. So if my answer is greater than that, that means I found something minimum. So I update my answer and I update my LR. Once I have updated the LR, this entire loop handles everything, and I just print answer L, answer R. That's it.
बाय द वे हमें टोटल इन्वर्जन निकालने की जरूरत नहीं है.
हाँ?
हाँ
Oh,
Total
total
हमें
निकालने की
टोटल
जरूरत नहीं है.
हाँ बिकॉज
अरे हाँ,
ना
fair.
इन्वर्जन्स डोंट चेंज. सिर्फ दैट रोटेशन में जो चेंज हो रहा है सिर्फ उतना ही चेंज होगा.
That is
Nothing
this
else
part.
changes.
Basically, this part remains constant throughout. So you can just minimize this part. Fair enough. Fair. I calculated inversion because I thought answer print करना था. But then I checked answer L, answer R करना था. So I updated the code छोटा सा. Now moving on to E. E में you want to place 500 less than 500 point, basically flags in a grid, basically coordinate system. I need to basically place points such that there are exactly k pairs of I comma j, such that this is equal. What is this? This is the Euclidean distance, which is under root of x minus a, like xa minus xb whole square plus ya minus yb whole square, and this is the Manhattan distance, which is the absolute value of xa minus xb plus absolute value of ya minus yb. Now when are these two equal? Now there are many cases, but the easiest case, which you can figure out from the test cases itself, is, I'll write the equation. Square root xa minus xb whole square plus ya minus yb whole square equals abs of xa minus xb plus abs of ya minus yb. Now, when can I equate this? One thing I can do is I can make one term 0. If I make xa minus xb or ya minus yb 0, so what does it become? This part becomes 0, so it becomes square root ya minus yb whole square equals abs of ya minus yb. And technically this equality always holds because the difference is same. So if you take absolute difference and square and take square root, this value is going to be the same. So one thing you can notice, एक वैल्यू सेम कर दो. You can't do two values same because distinct integer coordinates. That is the. Now, how many, like for example, so now my approach was, now how I came up with a solution is, now let's say सबका x coordinate I'll fix to 0. Everyone x coordinate let it be 0. Then I'll do this till I can. For example, if I'm taking these points, how many pairs are there such that uh, this is equal, and the pairs is choosing any two of these gives me a valid pair, right? So it is NC2. That is my, if I choose, like for example, five different things, so my number of pairs is 5C2. Okay, does this make sense? Okay, I fixed the x value, y value I'm changing एक एक करके, but now choosing any two numbers in this, my equation is gonna hold because ये वाले तो सेम है, तो ये इक्वालिटी भी होना चाहिए मेंटेन. Yes, no? हाँ.
Yes. Yes.
So now this is good, but now the problem is I can't always make NC2 equal to k. No, k can be any number. So then what do I do is, simple thing, I keep on taking 0, 5, 0, 6. I do this till NC2 less than equal to k. And after this, what do I do? K minus equals NC2. And then now I start with, the next number start with n plus 1 and n plus 1. Then n plus 1, n plus 2, and so on. This will also go till some NC2 less than equal to k. And I can just keep on doing this till I satisfy k equals 0. So I'm literally, like, if you look at my code, I am literally brute forcing. My initial offset is 0. Now my count is the number of same things I'm taking. Now one, like, either I'll take 1 same, 2 same, 3 same. I go until 500. And if NCI is basically, I just made a function n into n minus 1 by 2. If NCI is less than equal to k, I push back add and add plus I. So that is there, and I increase my count, or else I break. And once I've taken the count, I offset the add, so that, why am I offsetting? That is very important thing. If I don't offset, if I just, let's say I start with 1, 1, 1, 7, 1, 7 will match with 0, 1. Not really, but I just didn't want, like, कैसे भी करके some kind of matching. So I am like n plus 1 से चालू करो. That's it. And yeah, and then I subtract
Yes.
k,
Yes.
and then I do while k is exists, and at the end of the day I print out the points. That's it. Simple.
I've also did like plus 23, but will it fail in system testing?
This one.
Yeah, you have did n plus 1, n plus 1. I have did plus 23 in x plus y for the next iteration, but like, will it fail in system testing?
No, 23 also works because I think 23 into 22, 23 into 21 is 253. Plus 23, I doubt it will fail. Like, I can't make of a case because there are many cases where this equality can hold. So I don't really know. We'll have to see system testing. क्या होता है? This can be a bloodbath question. Let's see the hacks. Which question is this? Successful problem. No one is able to hack this at least. Have people tried? Yes, many people have tried. Cool. So now moving on to F. F apparently is a well-known Pascal triangle plus Lucas theorem, which I don't really know about. So I don't really know about Lucas theorem. I'll look into this. You can also look into this. But I'll tell you how I solved this, which is a very hacky way to do questions, but works most of the time. So yes. So wait. I'll just copy my solution and I'll explain. Okay. So forget the solve function abhi ke liye. What I'm doing is I don't call the solve function at all. And this also I don't compare. I just okay. So now I took k equals 1. पहले तो हाँ. Now I'll explain the question. So हाँ. So you're given n and k. K is your starting point, single integer first row, and then the other rows follow this pattern. Okay. I didn't really look much into this. I directly coded this up. So what I'm doing is I'm making curve array 0 to I. If j is 0, which is this condition, I just copy the 0 wala part. If j is end, I copy j minus 1, which is brave dot back, and all the other cases j minus 1 XOR j. So I'm literally brute forcing and I'm printing the answer. Okay, let's see what is happening. Okay, I see that I am only getting 1 and 0. Let's try for some other k also. Oh damn, only 4 and 0s are there. So one thing to notice, if I can make for 1 and 0, I can just substitute 1 with k. That's cool, amazing, perfect. Now I need to figure out, given nth row, I need to print the row, right? You can't really do this brute force because memory it will take n into n plus 1 by 2, which is 1e6 into 1e3 into 1e6 plus 1, which is 3, 5, 7, 9. 1e9 like बहुत ज़्यादा. तो 1e9 है, तो 1e9 तो I can't store in memory or I can't iterate also. Good enough. Now I need to figure out some pattern over here. So now what do I see? At every power of 2, this is completely filled. If you see 64b completely filled. So there must be something related to powers of 2. Amazing. Now let's see how do I check for the other condition, like for other numbers, right? Now one thing to notice, if you see any number over here, if I let's say draw a midpoint, isn't it a mirror image? If you see left and right, if you just mirror it, बीच वाले numbers में same ही आ रहा है ना? Like you can just verify it on your own, but that is what I found out कि भाई if I just compute left, right is basically inverse of that, like basically mirror image of it. So that is fine, cool. Now my problem is, how do I compute the half part of it? So now computing the half part of it, let's say I want to calculate 42, okay. No wait, easier example, I want to calculate 14. Okay, 14 ka half is where? 1, 2, 3, 4, 5, 6, 7. This is the half part of 14. Baki ka is mirror image. Cool. Now ये half part of 14. What do I see over here? I see this part. And what is this? 6. If you see. And what is 14 minus 8? 6 only. So basically, from this I noticed that once I split into half, the pattern I need to make for the half is max bit, which is 8, n required minus max bit. So for example, I need to make 14. I split the 14. Now I need to make 6. How do I make 6? 6 I make 14 को I split किया. 14 minus 8 is 6. Now I just make 6. Then now I need to make 6. Now 6 के लिए I once again split 3 3 में. Now 6 minus 4 is 2. Now I need to make a 2. How do I make a 2? 2 is a power of 2. तो वो तो sort है. So that is how I came up with a solution. Ki now basically for every sub problem, I'll basically keep on dividing this array, and then mirror image and make the entire array. Does that make sense?
Yes.
So then now how do I do this? I basically do divide and conquer. This I can do better in lot of ways, like literally a lot of ways, but this is what I came up with. Ki agar it is a power of 2, I just fill that entire L to R. Okay, and not R required, because for example I need to fill a 2 over here. So abhi I don't fill this entire required part, I just fill 2 ka part. So I just go to required. That is the main observation. So agar power of 2, and this is a very easy check for a power of 2. You can verify this on your own. But in short, a power of 2 in binary form is 1 followed by zeros. And n minus 1 is all ones. And this bit 0. So if I take an AND, it's gonna be a 0. And only power of 2 has this property, so I can just check if it's a power of 2 or not. Now, for the other, I take n. N is what? What do I need to make? Technically, n is not required. You can just go for required. I am stupid. You can do it much easily. And then I take the split point, and then once I get the split point, now this is where like that is why you require required instead of n. If you're taking n and you take the MSB, you need to make sure that if required is less than n, I basically shrink the right hand side of it. So basically make sure कि the n is equal to required. So I did a very roundabout way to get to this conclusion, but you can do it in much better way. And then what do I do is I split the जो split point है, and जो required, my required changes to required minus MSB. MSB I calculate by built-in function which is CLZLL, which basically returns the leftmost set bit, and this fun, तो उससे MSB का power मुझे मिल गया, and then my required changes. Once I've computed the left part, I just mirror the right part. जो R minus 1 to L है, I just mirror this, that's it. So that is the main logic behind it. And then yeah, you get, and then you place it. Now to verify this, what I had done is, now I'll copy paste my code. To verify, I literally did a brute force. I got the vector from the solve function, and then I checked if they're not matching. I had many cases where they were not matching. So 13, for example, was not matching. So I printed out 13. I printed out LR and required, and I saw कि भाई किधर it is failing, and then I debugged it. So that is where it took time for me, mainly debugging. And after I verified कि 100 तक चल रहा है, I knew for sure 1000, 10,000 सब चल जाएगा. So I just literally, then I just solve the question. Do the required task for the question. That's it. And yeah, I got a WA because I didn't verify. And once I verified, I got a miss. That's it. G I couldn't solve, but I had some observations. I think end root n में चलना चाहिए, but one part of the equation I couldn't solve, so I just left it. Any other doubts? If not, I'll end stream.
हेलो जी का क्वेश्चन नहीं समझ रहा है वो समझा देना एकदम
हाँ हाँ जी समझा देता हूँ. I'll
हाँ
end stream then. So bye bye stream. See you next contest which is tomorrow.